Everyone, I am one day. I open new chapter, chapter 4, estimation. What do you want to know? Okay, let's see estimation. Estimation is important part in order to understand statistics framework. Estimation refers to the process of determining an unknown value. Estimating by a single value is called point estimation, while within a certain range is called interval estimation. Let's see some simple examples. How long will it take to get to the top? While climbing a mountain, sometimes we want to know how many minutes to left to the top, that kind of thing. Okay? How many beans are in the jar? What is the length of the largest mullet in the fish farm? Okay, largest length, unknown value. What will be the batting average of a baseball player for this season? So at the beginning of a season, many persons say forecast, not estimate. I think forecast is has a similar meaning with the estimation, but the forecast is estimating an unknown value in time series data. Let's next next step. What is the taste of a boiling kimchi stew like? Okay, kimchi stew is boiling, so that cook wanna know the taste. In the meanwhile, so the kimchi stew taste is not a known value, so that kind of thing is also in estimation field. As you know, there are countless situations where we seek to determine unknown values. So how can we determine the unknown values? We must have data, say sample, right? And make estimation using appropriate method. We need to know which statistic obtained from the sample should be used for a suggested estimation. Okay, let's see. First, let's focus on the estimation of population mean mu. There is a population. So there are many data in here in the population. So of course, we do not know the mean of those data. Mean is mu, okay? Estimate mu, we need to obtain a sample and estimate mu using the specific statistic from the sample. So, we have a sample. From this sample, we get some, statistic to estimate mu. Okay? Estimate. Two terminologies here. Statistic obtained from the sample. What is this sample? This sample is what? Denoted by random variables, capital letters. Okay? Statistic obtained from this sample, then the result, the statistic, gonna be random variable, capital letter. That is used for purpose of estimation. Used for purpose of estimation is called an estimator. What is the estimate? The value of an estimator. How can you get that value of an estimator? From this sample, small letter sample, realized value. Okay, small letter. Can you distinguish capital letters and the small letters sample? Okay, it is necessary to understand well. All right, next. They are criteria for estimator, desirable, unbiasedness and efficiency. Those two new terminologies, I think, for you. Unbiasedness is a little complicated concept. Okay, let's see. Property of estimator, when each estimator's expected value equals a parameter being estimated. Okay, let's focus on mu. Okay, we have a sample x1 up to xn. Okay, then somebody wants to estimate mu by x1 plus xn divided by 2. Then this one is his estimator for mu. Understand? That let's take expectation of this x1 plus x2 over 2 is 1 over 2 expectation of x1 plus xn. Then 1 over 2 here, expectation of x1 is mu, expectation of xn is mu. We don't have to worry about subscript 1n, same x. So 2 mu equal mu. Then this simple estimator is also an unbiased estimator. Okay? So there are many unbiased estimator for mu or for any parameter. X bar is unbiased estimator, of course, because expectation of X bar is mu. Expected value of estimator is equal to mu. We are going to use X bar to estimate mu, right? So parameter being estimated, then we call it unbiased estimator. S square is unbiased estimator of what? Sigma square. Today's main problem is this. In other words, expectation of S square, capital letter of course, expectation of x1 minus x bar square up to xn minus x bar square divided by what? N minus 1. This gonna be sigma square. Okay, you will see it later, I think. Anyway, this s square means this capital letter expressed by capital letters is an unbiased estimator of a sigma square. When we calculated sample mean, we use this one, small letter s square, because we had small letter x's, realized values x's, small letter, x1 minus x bar square up to xn minus x bar square divided by what? N minus 1. We call n minus 1 is an what? Degree of freedom in this case. Okay, remember, divide by degrees of freedom n minus 1 instead of n. Do not use n, because dividing by n minus 1 makes s square unbiased estimate of sigma square. This is small letter, so I use estimate. Okay, okay, important result. Another important result here, x bar is, I'm gonna repeat later. Okay, that's why we divide by degrees of freedom. It is just theory. Right now, you at this step, you better understand. Okay, simply divide by n minus 1. Some textbook says when n is greater than or equal to 30, big size sample, then divide by n. Less than 30, then divided by n minus 1. Two ways, but it is not reasonable. Every computer calculate s square, value of s square is this way, divided by n minus 1. Okay, efficiency refers to when one estimator has a smaller variance than another estimator. Then former, this one, smaller variance, is considered more efficient. Okay, so among unbiased estimator, this is more important. Among unbiased estimators, the one with the smallest variance. There are many unbiased estimator. Okay, many unbiased estimator. Among them, smallest variance, the one with smallest variance is considered best estimator. X bar is the best estimator of mu. When mu is unknown, then we can estimate it by X bar. S square, this way, okay? S square is the best estimator of sigma square, capital letter. Here, S square is capital letter. Sigma xi minus x bar square from 1 to n divided by n minus 1. Okay, this one is the best estimator of sigma square. These two results you anyway, you have to remember, memorize these two important results. Okay, this is it today. Thank you. Bye.